Okay, I do think that this is a slightly heavy-going core 3 paper, quite a tough core 3 paper, because this isn't that simple a question either. The diagram shows the curve 3x minus 1 to the power of 4. The point P on the curve has coordinates 1, 16, and the tangent to the curve at P meets the x-axis at the point Q. The shaded region is bounded by PQ, and that part of the curve for which x is between a third and 1. Because of course the third is where the graph meets the x-axis, isn't it? Find the exact area of this shaded region. Right. You know, once again, this is becoming a reasonably common thing, isn't it? Have you noticed this as you look through the past papers? The idea that we get an integration question about area, but there's something about it at the start that means it's also a differentiation question. And they quite like doing this, getting both bits in here. And it may not look immediately like it is a differentiation question, but in order to do this, we need to know the coordinates of Q. And to find the coordinates of Q, we need to know where this tangent meets the x-axis, and to do that we need to know the equation of the tangent. To find the equation of a tangent to a curve, that's what you did in core 1 with differentiating to find the gradient of the curve, and then find the equation of the tangent. So it's all linking in all sorts of things from all over the place. What we're ending up with, what we're aiming towards, is thinking about this triangle here, and being able to subtract this triangle. That's the point 1, isn't it? That's the point a third. That triangle, then we want to find that area so we can subtract it from the integral underneath the curve, and that will give us the shaded bit. But to find the area of that triangle, which I will highlight yellow, in order to find that, we need to know the coordinates of Q. So that's the first thing to recognise in this question. Actually, before we do any integration, it's about finding Q. Right, so to find the coordinates of Q, I need to know about the tangent at the point P. If y equals 3x minus 1 to the 4, then dy by dx is, well, this is a chain rule question again, isn't it? So it's the derivative of the whole thing. If you differentiate something to the power of 4, you get 4 times something to the power of 3, multiplied by the derivative of the inside bit, and the inside bit differentiates to 3. So actually this is 12 times 3x minus 1 cubed. And what we're interested in is what happens to that gradient at the point P, because it's the tangent at P. So at P, which is the point 116, dy by dx is 12 lots of 3 minus 1 cubed. Well, that looks to me like that's 12 times 2 cubed, which is 12 times 8, which is a pretty crazy gradient, isn't it? Is that 96 that we've ended up with as our gradient? Okay. So, we've got our tangent, goes to the point 116, and has a gradient of 96. And remember how we can find the equation of a tangent, again, way back to core 1, y minus y1 is mx minus x1. Now all we really need to know is what happens when y equals 0 here, because we want to know the coordinate of q. So we could at this point just sub in y equals 0, but I think it's nice, isn't it, to finish it off a little bit. So we've got y is 96x minus 80 as our equation. At the point Q, y equals 0, because it's on the x-axis. So if y equals 0, 0 is 96x minus 80, so x is 80 over 96. Are you alright, Eva? Have I made a mistake? No? Not yet. Which gives us x as being 5 over 6, yeah, 10 over 12. Okay. It feels like that's a reasonable answer, doesn't it? We're pretty happy with that as an answer. Feels okay, because it makes our diagram look reasonably alright. If we think of this as being split into sixths, that's 2 of them to that point. Seems reasonable. That's 5 of them to that point. It's about right, isn't it? So that point is the point 5/6. Great. Right, now we can think about finding this area. So the shaded area the shaded area is the area of the whole thing, the integral from 1/3 up to 1 of the curve, which was 3x. Was it 3x? Sorry, 3x minus 1 to the 4. That's the whole bit. Take away that triangle. And that triangle, I think I've just worked out the area as being half base times height, and that's a half times the base, which is a gap of 1/6, times the height, which is 16, isn't it? Because the y coordinate there is 16, that height is 16. There we go. So we've got integrate this would be add 1 to the power, divide by the new power. But we've also got to divide by the coefficient of x there as well, haven't we? So that's 5 times 3 between 1/3 and 1. And from this answer we are taking away 16 over 12, which is 4 over 3. Like that, I think. So put this all together, we've got, put the 1 in there, that is 2 to the 5 over 15. Take away, put in 1/3 there, and that would be 0. Minus 4/3. So that's, is that 32, isn't it? 32 over 15. Minus 4/3, that's 12 over 15, is that 12 over 15? Which gives us 4/5. Brilliant. There we go. And that was the answer they were looking for. Find the exact area of this shaded region. They've been a bit kind in the end, haven't they, actually, because you're going to struggle not to write 4/5 as an exact answer. Right, it's 0.8, you should get that. So there we are. 10 marks for that. That's pretty good, isn't it? Right, and that's maths.